Hello and welcome to Weizman channel. This is my journey about reading my car. This is an old Hyundai car that I have, and inside of this chip or key fob there is a little chip or a car immobilizer that is based on Hitag2 crypto. Now, old research made this readable and crackable 2007 and forward, so there's very old stuff. So when I get into the Proxmark world 2013, this was already doable, but I was not good enough to make things work and happen. During the years that came later on, stuff happens. I bought an RFiddler, I still didn't manage to do things. There were Kevin Sheldrake's amazing toolkit troopers, where he went in and looked at Hitag research like 10 years later from original release and talked about it. And then there was Hellgate or something like that, was the GPU implementation by same Dutch researchers, Azid and other people, making an impressive implementation of it. And from there on, in the Proxmark world, around 2021, we made a improved version of a GPU brute force for Hitag2 cryptos, and a specific one attack where we only need 2 authentication attempts to recover the key. And that was built by Matrix. He's one of the contributors to the Hashcat team, so we got a little bit of Hashcat crossovers, and you will find me doing a little bit of Hashcat in this video in order to show you what I needed to do. So what I had when I started out is that I'm running on a Windows machine. In order to run Linux machines, I don't have a native bare metal Linux. I have some Raspberry Pis, but I don't use it for that. Instead, I use virtual machines, and I bought the VMware Workstation Pro, which allowed over some years to have GPU access, which I thought would be finally I can use my virtual machines and run the GPU attacks on there. However, that was not true, because VMware decided to just allow 3D accelerated access. So it can accelerate it, but it's not, you don't have access to the raw device. Kind of annoying. What to do? Well, then Microsoft, about the same time, started releasing something they called Windows Subsystem for Linux, version 1. It did not have access to GPU. That was sad, but you more or less got a Linux environment at your hand inside of your Windows machine, just like that. And you didn't have to pay license fees for it. It also had a USB to serial, so I could just download the Proxmark repo, code and compile and run it out of there. It's been excellent. I've been using it for ages now, since I went over to VSL. That's like 7-8 years or something like that. One thing I got Scott Hanselman to be a little bit upset when I was a little bit tired about VSL-1 not having good access to something. Side note. Since then, WSL-2 came out, and there's also a WSL-3 coming out, but WSL-2, when Microsoft released that one, had some improvements. First of all, their disk access, the disk I/O was much faster. So it's comparable with my virtual machine. For VMware, it's kind of the same. It also had access to a GPU, which is great, what we want. But they removed USB to serial access, meaning I can't just run my Proxmark like that. You would need a TCP bridge, another software, in order to do it. And I don't like that. However, I notice now, because Microsoft being so great in that sense, how they've been supporting the VSL, they do allow VSL-1 to run parallel with VSL-2, meaning I can have VSL-1 for Proxmark development and all access to other USB serial devices like Chameleon Ultra, Flipper, the RFiddler, Proxmark, and stuff like that. Kind of good. And then I can run in parallel this VSL-2 to get access to the GPU. That's great. So what was my problem? Yes, VSL-1 was its own little virtual heaven. and it didn't have any problem working side by side with VMware's Workstation. How? Because they have their own hypervisor. However, WSL-2 used something called Windows or Virtual Machine Platform, and that's basically using Microsoft Virtual Hypervisor Virtual Engine. And those two compete about the same resources in the CPU. So we don't like it, so it crashes. That's kind of annoying. And then my next problem is, even if I'm in the GPU or in WSL-2, I need to get access to the GPU in the way that I want it. And using, because the cracker, the brute force we're looking for is using OpenCL, Open Compute Language. And straight out of the bat, WSL-2 supports CUDA. So that's two problems that we're going to address in this video, and I will show you from scratch to hero how to do it, or how I did it, and you can just follow my footsteps and you will be able to do exactly the same things. To begin with it, we would need to look at the WSL settings that you have. And to do that, I use the Windows terminal as another great improvement of what's already there from Microsoft. So they made a better command shell. Oop. And then I have access here. Starts this one. I have no need for that one. That's my normal default shell. So this is the Windows command prompt now. So now you're in command talk Windows terminal with administrator rights, and you are going to look at command WSL, and you want to type in help. It gives you a whole heap of different things, options. You want to make sure you want to look at list, and you see this is what I have installed. You will not have anything installed there, but we can get a list of which available Linux distros I want to install that I can do, and we type in WSL-list-online, and you see that we can do all of these ones here. Here's a trick. When I do mine, I have already two installed, and if I do with V, I can see which version of WSL I'm running. So this is version 1, and this is WSL-2. I cannot install this twice, so I need to select one of these distros up here that is not the same as I've already done. So I will take this one, 22, and I will just do install Ubuntu 23.04. And I will edit some out of here because there's a lot of these things going on. They ask you for a username or a password. Again, yes. How about I type in the password correctly? Here you go. That's it. It also drops me directly into this Linux distro. You see, I'm in Ubuntu 22.4 free already. So if I type exit, I will get out to my Windows command terminal again, right? And if I look at list here, you see that I have a Ubuntu 22.4 running version WSL-2. So if I want to start this one up, I do, let's go up and see what it says up here. It says -D. Okay, that's all I do. I don't have to stop. Let's do this. And I want to run this one. There you go. And I'm inside of this shell. All right. I want to cd out because I want to be in my home directory when I start this one up. You do that by typing cd, it jumps to your home directory. You can see pvd, off to working directory, and see I'm in here. Now comes the biggest part. There are a whole heap of things to be installed in order to get this to work. And I will try to do this as easy as I can. First of all, you start with sudo apt update sudo apt upgrade -j sudo apt auto remove. This configures the whole apt system, pulls the latest stuff, and updates a whole heap of things. I'll make it a little bit smaller, maybe like this. Okay, we got that. First thing I want to show you is the NVIDIA, to show you that we got access to the graphics card of the GPU already in WSL-2 like this by running the NVIDIA-SMI, which is nice. It means that we have access to it. WSL-2 reaches the graphic card. Good. But the software is not able to talk to it yet. So we need to install a whole heap of things to do that. One of the things that I do when I set up this environment is I install a lot of programs, and I want to install valgrind, ripgrep for fast searching, and something called CL info. That's computer language information. You see it's a kind of big ones, but you install it anyway. Great. I can type in CL info and it says number of platforms 0. It means that OpenCL has no way of reaching the graphics card yet. Because the graphic cards, what we have here is CUDA based. You do not install any, this is for NVIDIA RTX. If you have AMD or Intel's graphic cards, you have to do other things. But we need to install more things. One of the things I install is the requirements for Proxmark libraries, with the build essential, package config, reline, all that stuff. This takes a whole heap more, almost 1 GB of data. For NVIDIA drivers, you don't even need to install a new driver. Don't touch anything like that. You go to NVIDIA and do wrong things. Follow these steps here now. I will show you, because you need to install the CUDA toolkit. That is done here in this one. Oop. So if you search for CUDA toolkit 12.4 is the latest downloads, but I will give you a link to this one later on. And then you will click in Linux, x84 is what I have, WSL Ubuntu 2.0, and I choose to do network, this one here. And it gives you these installation tricks. So I need to do this, and I go over to my command prompt, and I do that. Copy paste, and then I take the next command. I do that. I do sudo update. And since we added the NVIDIA package repo we now have available to get what's in there, and we want this to CUDA toolkit. Nothing else, nothing more. It's also 3 gigabytes of data. So you're already at 4 gigabytes of data, and we're not done yet. While it's installing, I'm going to go over to this page again. This is where you want to be. Toolkit 2.4 right now. And you want to install according to your setup, of course. But there's a point where you have to go here. You want to go there. And in here, there is a subsection that you want to reach. And it's called post installation actions. This one here. In here, it tells you install some environment paths to your shell. And what you want to do is install this and this. So I have a 64-bit version. Have a 32-bit version of the OS, you go there. I have 64. I will copy that one. And I will go back to this terminal and wait for the CUDA toolkit 12.4 to install. Alright, CUDA toolkit 12.4 is installed. Now, can't forget, install the paths in the shell, and I will do that by going to, or I will edit a file called bash.rc. If you don't know what that is, that's your user settings for your shell, for the bash shell. I use Nano to edit. You go down to the bottom of this file and you paste in the first thing, and then we go over to the second and we go copy that one and go back, we go here and then paste in that. And I don't want to have an extra line like that, so I remove that. Alright, I save by pressing Ctrl S and Ctrl X to get out. I type source.bashrc in order to reload the shell environments. I can now look at the environments available here, and we see that this path has been added to it. And that's the whole thing with this exercise. Now the CUDA toolkit 12.4 is configured correctly. We now need to do the next steps. Enter Hashcat. I clone from GitHub the Hashcat repository. I go into Hashcat folder and look at the code. It's kind of straightforward. I think it is just type J. Long outputs, I can make it a little bit smaller so you can see it a little bit better like this. The reason why I use Hashcat is, as an example, you see we have Hashcat here, that's the executable. The reason why I use Hashcat is because they have a very good way of looking at available devices. And they also filed code for CUDA and OpenCL. And here you do -I, capital I, to see what devices Hashcat can see. And you see here that it doesn't find any OpenCL, but it finds a CUDA. So it finds the GPU, and you can run Hashcat against this GPU now, and it's all done. But if I go into a Proxmark world, this will not be working. And I will show you that by downloading and git cloning Proxmark repo. I went out of a Hashcat folder, and now we do a git clone for the Proxmark repo. I go into the Proxmark folder, and under tools, and under Hitag to crack, and then it's OpenCL. That's where we want to be. And if I type make, it builds it, and it doesn't like it because it can't find an OpenCL. So the brute forcer here uses OpenCL. Even if we have CUDA and access to CUDA for Hashcat, we don't have it yet. And this is where I got stuck a long time ago. I will show you how to solve this problem now. It's not about the installation for posts for CUDA. This is CUDA. That's it. What we do have is OpenCL from Kronos Group. They made an excellent alternative to NVIDIA's closed source OpenCL and license feed, and they have made something they call portable OpenCL. So this is the pocl. This is the portable computing language by Kronos Group. This is the GitHub for it. And their installations are a whole heap more complicated. It says this, but it's not that simple. So we need to have version 18, or the latest one, of the LLVM. It has a little tiny link to it. Let's see if I find it here. It says that you can, if you want OpenCL 3.0, you need to do this. And we don't want that. We want here. We go here. We come to LML Debian Ubuntu Nightly packages. And here we have to do things. We need to do this. And if you don't want to download a scary shell from the internet, from this place here, download it manually yourself and look what it does. The even worse part is when I copy this and I go in here again, we do need to run this as sudo. That's the first thing. You're gonna love this. Great. And let's see. Now we also need to clone the source code repo. We do that by git clone github.com pocl, and we go into pocl like that, and do ls. So we're inside pocl there. Now this one here has an even longer installation demands. If you go for, we've done this part, so we're done. It says that you need to do all this as well, and yes, and all heap here. Let me show you what I did. I did first, I have cut this up a little bit. So first I installed this software because you need it, and that's it. And if you go into here again and look at this here, you see the latest one that I installed for Ubuntu was for Jammy, and I want the latest one, that's 18. Okay, so I want 18, and it also says it says here that you need to do like this when you install that. You could do that, or you can actually just manually cut and paste out that and edit it like this. So this is the next step of things that needs to be installed. I told you, this is so much to install. And that's done, clear. All right. What more? This is this build option of this. This is just the normal build, how we build pocl, pocl. So let's do that. Make build cd build remake dot dash dash. And if you did something wrong, it will complain here. But it didn't. Now, I would show you to just build it like this, make -j. And there's lots of warnings coming up in this code, but it will still compile and install. Don't be alarmed by that, about this. It's just warnings. Alright, the shared library is created. Let's type cl info. Remember we installed that program? Check compute languages. It doesn't do anything right now. So we're going to make install for the system to see what's up. And nothing still. Interesting. Let's get into Hashcat. And let's see what Hashcat, Hashcat says. Capital I. Bummer. We need something. We missed something. And you're right, we did. And we go back in here. there is we built this one, so that's fine. Problem here is that it links to a nice little installation for this pocl and documentation. It gives you all this how to requirements a little bit more. You will find it from somewhere. Don't find it right now. Anyway, it's here. It will give you all the different extra options you can do. So this is an indication that you can do cross compilations. Doc files, risk. But there's also something called enabling CUDA. Let me see if I find it. There's spot for CUDA. Here we go. Here. All of a sudden we can enable that with on and off. Okay, cool. And there's more than that. I found on VSL, a GitHub for VSL, and Microsoft's repo, one of the issues is 6951, and it's this message here that he actually I'm following. So this is what we're going to do, what he did in order to enable this. And he explains a little bit more why you need all of these things to be installed. But he gives you this. This is what you need to build with enabling CUDA. So let's do that. So you tell where is different libraries. VSL has a path for its own folder where the CUDA redirection libraries will be. Enable CUDA on. All right. So make J. We rebuild this one. With CUDA enabled. So the portable open compute language, the pocl, now links to the CUDA drivers that's already installed on 4. The warning messages. Alright, so here we see it's a pocl shared library with devices CUDA installed. And here is a tricky part. In his suggestion how to build this, and he shows it off, he also has 2 little things in the bottom that's so easy to forget. This did the trick for me. It wants you to add these 2 environment bars to point it to your local build. So while we're in the pocl build folder, we do export pocl building equal 1, and then we do IOC vendors, but it's going to go to the path pocl build OCL vendors, and that's it. So if I type in CL info now, it now sees my little GPU. So we now have access to that. Oh. Let's go into Hashcat and see what it says. And now it sees both a CUDA version and an OpenCL version. There's two different ways to talk to a graphics card now. Now we are ready to go into the Proxmark repo again, under tools, anti-crack, crack 5, OpenGSL, make clean, make K, and now if we do crack-s, it sees the GPU. And now we're all super excited. Everybody's super excited to test it out. Yes, and let me show you how to get some demo stuff to work on. We also have a generator who can generate some valid data for you. So if you go back one step or up in the folder and we look, there is something called Hitag generator RAR. And if you run it like this, it says call it with key, UID, and numbers of nonces to collect or generate. So we set a key, it's 6 bytes, UID could be anything, that is 4 bytes, and I want 2 sample sets. And now we have everything in order to run and test this out. I need to call it with UID and the rest. This is my UID. This is the first. And this is the second. And if you run that, hopefully it will find the key. Let's see. I wonder how fast this would have been on an RTX3090. And, you know, don't be ashamed to send one little of those beautiful puppies over to me if you have one extra laying around. Or you feel like supporting. Speaking of which, if you want to support me on Patreon, love to have you there. Please like and subscribe, you know, and show your love for all this, what we do. On this computer, on this GPU, it takes me 105 seconds to exhaust the key space. And I was really hoping that it wouldn't be this complex number. Oh, this is interesting. If I have to change that on this computer, this is why we have ripgrep. And if I search for this, whoops. In the source code. Let's see, I have to do this because it doesn't like this is a regular expression, so I have to escape them now. It gives me here, but if you get the following error, change to pi. And this HT2 crack, you can see it so well here, but it says H2 crack OpenCL. You can change something. So let's do that. Let's do and change that for you, and not a header. We go for that and do that and do this. And we're looking for CL and U. No, CL and U. Here we go. It uses the factor mid, which is not, so I should change to full. I go that and that. Compile it. And then rerun this. That's actually good that that bug came up. So we got a bonus how to fix that one. Since this is also made with Hashcats in mind by Matrix, it also supports multiple GPUs out of the box. So if I had 2 or 3, it would be going quite much faster, because the scheduler in here is quite similar. So that's good. Let's see if it crashes about 10,000 before. And we pass that now. And found it! Look, that's the key. Took 85 seconds, sorry for that. With that all in mind, all these complications, all these downloads, all this installing and doing things in order to make this little software run on WSL-2, I'm kind of happy. So I can now sniff and collect the data traces using the RFiddler or the Proxmark near to the car, in ignition, and then I will extract the data needed to run this command to extract the key or recover the key, and then I'll be able to read all the information out of this key fob, which I did, and now you can too. Please let me know in the comments below what you think and your experience about this, and have a good one.